Okay, so you should have received a link in the email. So just go ahead and click that link to open up Google Colab. And I've put this text in to begin with. It's some sample English text and a code. This is the code that we're going to break. And this is a cipher, so every letter in the plain text has been replaced by a letter of the alphabet. So, for example, maybe A has been replaced with L, B has been replaced with Z, or whatever, and that's given us this encoded message. And the plan is that we are going to count up how many times A, B, C, D occur in the ciphertext, and then count up how many times A, B, C, D occur in the sample text. And the thinking is that if, for example, K is the most common letter in the ciphertext, then it's probably the case that K represents the most common letter in English. And so first we need to figure out what's the most common letter in English. And for that, we are going to have a look at the sample text and count up all of the letters in there. So go on up to the top and click on File and click Save a Copy in Drive, and this will just make a copy of this file that you can edit and save into your Google Drive. And you can close the original one, and this is the one you'll edit. So first thing we're going to do is we're going to import our string module. Remember, that's where we get the alphabet from, so we don't forget letters like V, like I did the other day. And down here, we're just going to store those alphabet characters in a variable called alphabet. And to run that code, just click on the play button and give it a moment. It'll show that it's connecting and setting up a computer in Google's data center to run this. And this won't print anything out, this because we haven't run any print commands yet. I'm just switching to a different microphone, by the way. I was getting some buzzing off that one, so I hope that doesn't sound too weird. Anyway, next we're just going to make sure that that alphabet is stored correctly. So let's print it out. Print alphabet, and to run it, of course, just click the play button, give it a second. There we go. So we've stored the alphabet there. Next, we just need to iterate through it and do a count for each letter. So we're going to count up our sample text first. So let's use a for loop. For letter in alphabet, colon, indent, and then we'll do sample text dot count, and then count the letter that we're currently on, and then we'll print out all of that. Print, and let's run that, see what we've got. Yep, that looks like it's working fine. I'm going to print the letter as well, so I'll put letter there. You can just put a comma, and that will just separate them nicely. Away we go. So E is the most common, 109, okay. I'd like a bit more visual feedback here, though, just so I can see at a glance which ones are the most common. So I'm actually going to save this in a variable, and there's a kind of a neat but lazy trick for this. I'm going to store this in a variable, so number of times equals sample text count letter, and then I'm going to print out that number as we did before, and then I'm just going to take that same number. And remember, with Python, you can multiply numbers by strings. So I'm going to multiply that number by just a single character. And that'll give me a really lazy, cheap kind of bar graph printout of how many we've got. So let's try that, see what that looks like. Yeah, it's not bad. It's far from perfect, but it's kind of handy. I definitely don't think I could have created a bar chart any other way with so few lines of code. So we've got, what have we got here? E is the most common, and then T, then A, O, N, R, and so on and so forth. Right. And what I'm going to do now is I'm just going to wrap this whole thing in a function. So we do def, and then give the function a name. I'm going to call this letter count. And then it takes in a single argument. I'm going to call that text. Don't forget the colon and indent everything. And then I just need to change the name of sample text to call it text, because that's the name of the argument that gets fed into our function. And of course that's not going to print anything because I haven't called the function, so we need to come down just below there and call the function letterCount, and then pass the sample text into it. Sample text, and then if you run that, should all look great. Yeah, that looks good. And we can put anything we like in there, obviously, to give it a test. Let's put something else in, see what that gives us. Should just behave itself, which it does. Great. There's lots of nice things you could do for this, by the way. You could find a way to maybe not print out lines that are 0, for example. Now, next thing we want to do is have a look at our cipher and start making educated guesses about what these letters represent. So let's do a letter count for the ciphertext as well and see which are the most common letters there. So jumping down here, I'm just going to call my letter count function again, and this time we're going to do letter count on the ciphertext. Okay, so what can we see? We can see E is the most common letter in regular English text, and if we come down here we can see that H is the most common letter in the ciphertext. So this gives us a very good reason to believe that H probably represents E. Not a guarantee, but likely. So this one is probably an E. Okay. And so the next thing we want to do, I'm just going to comment that out. And next we want to think about how we're actually going to substitute in our guesses. So that's what we're going to do now. We're going to build some code to go ahead and print out our guesses. So we want to be able to print out the ciphertext, and then underneath each line I want to print my guess for what that line actually says. So what I'm going to do is I'm going to split the ciphertext into a series of lines, because remember that each line ends with a new line. So I'm going to say split at the new lines, and what does that give me? This will give me a list where each member of that list is a line of the ciphertext. I think it starts with a new line, which is why I have an empty string at the start, but other than that, that looks great. I've got this list of all my individual lines, and now I want to go through and I want to print a line followed by my guess for what that line says. So I'm going to do for line in ciphertext split, and then I'm going to print the line, and then underneath it I'm going to print my guess. So for now I'm just going to put in a placeholder thing. I'm just going to put a bunch of dashes or underscores just to make sure that this kind of makes sense. And yeah, you can see that it's printing out a line of the ciphertext, and then underneath it prints out the next thing I want to print, and that's going to be where my guess goes. But this is kind of behaving itself pretty well. So now we want to find a way for Python to let us start substituting in our best guesses. So like if we think that the letter D represents X, then there needs to be a way for us to take the ciphertext and substitute in and replace all of those letters that we have guesses for. And it turns out there actually is quite a nice way to do that. So what I'm going to do is just above this code, I'm going to create a new string, and it's going to store all of our best guesses for what the alphabet should be to decode this. I'm going to call it my guess alphabet. And it's just going to be 26 characters. And have a look at this. Above it, I'm just going to put a comment line, starts with that hash symbol, and I'm going to put the alphabet above it, just all the letters of the alphabet. And beneath them, this is just so I can see where these letters should go. Beneath them, I'm going to put my guesses for what those letters represent. So in the cipher, if I if I have a good guess and I reckon that A represents J, I can put the J underneath it. If I don't know what any of these letters represent, I'll just put an underscore. If I think that the letter W represents S, I'll put one underneath it, and that's it. That's one possible set of guesses for what all of these cipher letters represent. And so now I want a way to stitch those together so that Python can go through one of these lines and replace every A with a J, every W with an S, and so on for everything else. And gradually we can fill in our code. And we're kind of fortunate that there is a nice way to do this. And Python makes it quite available. So have a look at this. When we decode things, we frequently use something called a decoder wheel. So I'm going to call my variable decoder wheel. And this is where we're going to store our decoding thing. So we're going to talk to string, the string module in Python, and use this function called makeTrans, make translation. And we feed in the regular alphabet here, and followed by the guess alphabet. The two things you feed in have to be the same length, so it can match A to J, and so on and so forth. And it will just stitch them together into a mapping from alphabet letters to your guesses for what they represent. So we've got our alphabet, and then we've got our guesses there, and then we're just going to stitch them together using this makeTrans function. And I'm going to show you how to use that in just a moment. We're going to come down here, and instead of printing off our junk line, we're now going to say line.translate using the decoder wheel. Nice. And if we go ahead and run that, yeah, you see now it's replacing W with S's, and it's just turning everything else into an underscore. And I don't think there actually are, I don't think there are any J's in there, because perhaps there are no A's at all. No, no A's. I chose a letter that just doesn't occur at all. So whatever. Just make sure that that string is always 26 characters. So away we go. Let's see if we can start chipping away at this cipher. So remember, we know that the most common ciphertext letter is H, so that probably represents E. So we'll come along over here and put an E in there and run that. Now what can we see there? You want to be on the lookout for 2 and 3 letter words. They're usually the easier ones to guess. So for example, you see we have WKH, which could represent the word the. So it would be useful. Something we can do, in fact, is just quickly count how many times WKH occurs in our code, because if it occurs quite a few times, then that's a good indication that it's a common word, like the or and. So let's do our usual bit of counting. We're going to do ciphertext .count and then just WKH. And away we go. Oh, whoops. Yeah, sorry. It's not written like that though, is it? Okay, so there's 8 of them in that short paragraph. So yeah, probably WKH represents the word the. So let's go and fill those in our guesses. And W is T, K is H, and there we go. So run those and fill those in. And what else have we got in there? Keep looking for short letters. We've got a 3-letter word, H-E something. There aren't many options for that. I'm thinking it could be her, and that's just about it. So I think it's a safe bet that U represents R. Let's put that in. And by the way, please feel free to just pause this video now and do this yourself. You don't need to watch me do it. But do if you prefer to. Double T, that looks good because T is one of the letters in English that you're allowed to have doubles. What else have we got here? Looking through. Oh, here we go. That can only really be the word weather. So it's a safe bet that that Z represents W. Don't know whether that's going to help us very much. Probably not many W's in there. I'm not sure what that is. WHITE, that could only really be the word white, I think. So let's say L is I, cool, let's try that. Here we go, that's filled in quite a few. There you go. Tired, T-I-R-E-D, G is D. Here we go. That looks good so far. What else can we use? Now to me, that could be thought. It's a bit of a guess on my part, but we'll see how that turns out. Try that. Yeah, this is looking good. And by the way, I've only just spotted that in fact these letters are in alphabetic order. And so this is a Caesar cipher. D, E, that has to be an F, G, H, I, and then we can fill in the rest from there. Right. You never know. I could be wrong, but that's probably it is. It's T, U, V, W, and the rest of our alphabet here. Maybe C, no. Does that line up correctly? Oh, hold on a second. That X, Y, Z should go at the front, obviously, because it's otherwise it's just not changing at all. So X, Y, Z needs to go there, and away we go. That's it. Alice was beginning to get very tired of sitting by her sister on the bank and of having nothing to do. Yeah, these are the. This is just the opening line of Alice in Wonderland. Well done, everyone, and have a think about whether you could write a code that creates these ciphers. It's really similar.